Hello guys, this is Miss Scott, and today we're going to actually jump to a section in chapter 11 because it deals with circles. So we're going to look at two sections in chapter 11 focusing on circles and then go back to some sections in chapter 10. So before we get into that, here is your bad joke of the day. How much space do fungi need to grow? Well, they need as much room as possible. Yeah, it's pretty good. All right, here we go. Section 11.4, circumference and arc length. So here's your essential question. Two parts to this. How do you calculate circumference and arc length? Pretty creative essential question, I know. So first let's look at some vocabulary. So if you'd like to go ahead and pause the video, get that essential question written down, and then jot down these three vocabulary definitions, and then we'll talk. All right, so now that you've gotten those written down, circumference is just the distance around a circle, and to abbreviate this, we'll use the letter C. Arc length is part of that circumference, and we use the letter S to represent that. And revolutions is just one complete turn of a circle, which is 360 degrees, and you can look at multiple revolutions. Oh, sorry, I just got a message. Anywho, theorem 11.8 deals with the circumference of a circle, so these are actually two formulas. First of all, you can calculate the circumference by taking 2 pi times r, and that r actually stands for the radius. The other version of the formula is pi times d, which is, you guessed it, the diameter. So depending on what the problem gives you, you're going to use one or the other. So in these first two examples, they want us to find a circumference with a radius of 5. So we're going to use the top formula. C equals 2 pi r, and here r is 5. So that's 2 times 5 is 10 pi. And you can leave your answer like that. Let's just make sure we put feet on as our units. All right, in our other problem, they give us the diameter. So in this case, we can just take pi times our diameter, and we would always write the number, the integer, and then pi at the end, and that would be 17 times pi miles. And of course, for both of those examples, you could plug them into a calculator and get a decimal approximation. All right, so now let's look at the main part of this lesson, which are probably the new part, this idea of arc length, which remember is part of the circle's circumference. So in order to calculate that, we need to learn a new formula. In a circle, the ratio of the length of a given arc to the circumference is equal to the ratio of the measure of the arc to 360. So if we write a formula here, this is actually a proportion. If you have the arc length and you divide that by the circle's circumference, that is actually equal to the arc measure, which is, remember, the number of degrees of that arc, divided by 360 degrees. So this is like part of their circumference over the entire circumference, part of the angle over the entire circle's angle, which remember is 360. And we oftentimes like to shorten that down, so we'll use some symbols. Remember, arc length is S, circumference is C, and that's equal to arc measure, which we use the Greek letter theta to represent that angle, divided by 360. So you might see where we're going with this. We're going to do some cross multiplying to find missing variables. All right, so let's jump into our first example of that. In this one, we are finding the length of arc ACB, so that's the arc length. So in this case, we are going to calculate S in that formula up above. So arc ACB starts at A, goes through C and ends at B. So I know that they give us 45 degrees, and you'd think that's what we're going to use for the arc measure. But since we're finding this major arc, we're actually going to do 360 minus that 45 degrees, which is 315 degrees. So that's our arc measure. And then the circumference, we have a diameter of 8, so the circumference is going to be pi times 8, or 8 pi. All right, so now we've got our formula. We are calculating S, so we're going to do S over our circumference, 8 pi, equals our arc measure of 315 degrees over 360. So again, guys, we're just filling in the arc length over the circumference equals the degree of the arc, or the measure of the arc, over 360. So all we're doing is just filling into the formula. Now we can go ahead and cross multiply. So first let's take 360 times S, or 360S. Over here, let's do 8 pi times 315. And I'm just going to write that down. And now to get S by itself, we can go ahead and divide by 360. And I encourage you to try plugging this into a calculator. I don't plug into the calculator until I'm to this point. So I don't touch the calculator until the very end. So we're going to do 8 times pi times 315 and divide that by 360. If you do that, I'm going to round and say that our answer is about 22 feet. And again, try that out in the calculator, make sure it works. So this is how you can find S. So this example highlights how to find the arc length. So that's the length of an arc, of arc ACB in this case. All right, now let's look at an example where we are going to find theta. So we're going to find the measure of this arc AB. So in other words, we're going to find theta. So again, that formula is S over C equals theta over 360. And you don't have to write that formula down every time. I'm just trying to make a point. All right, so let's fill in the arc measure. Actually, let's look at our picture here. They tell us the length of that arc is 8.73 units. They also give us the radius. So in order to find the circumference, we're going to take 2 pi times that radius of 10, which is 20 pi. All right, so we know S, we know C, the only unknown is theta, so we can solve for it. So we're going to fill in 8.73 for the arc length, 20 pi for the circumference, now times, that's equal to, sometimes this does this to me or it doesn't want to work, there we go, theta over 360. Go ahead and cross multiply. So we have 20 pi times theta. And theta is our variable that we're solving for. And over here we have 8.73 times 360. All right, we want to get theta by itself, so let's go ahead and divide by 20 pi. All right, these will cancel. And we're left with theta all by itself, which is our goal. That's going to end up giving you, if you plug in 8.73 times 360 and divide that by 20 pi, about 50 degrees. And if we look at our diagram, that seems pretty reasonable, so I'm okay with that answer. All right, let's plug along here. So we solved one problem for S, one problem for theta. We haven't solved one for C yet, so that might be where we're going here. It is! All right. So we are going to find the circumference of this circle. So let's see what they give us. They tell us the arc length from L to N. So this major arc is 61.26 meters, so that's our S. They give us theta in here. They tell us that's 270. So again, in that formula, S over C equals theta over 360. We know S, so we'll fill in 61.26 meters there. We don't know C, that's what we're trying to solve, so we'll leave that be. And then we know the arc measure is 270 degrees, and that goes over 360. Let's cross multiply. C times 270 gives us 270C. And over here, we're going to do 61.26 times 360. And we are trying to get C by itself, so let's divide by that 270 out front. So these will cancel, and if you plug in 61.26 times 360 and divide that by 270, you'll get 81.7 meters. All right, and again, that makes sense. I mean, it's got to be bigger than 61.26 because our circumference better be bigger than the arc length. Okay, one last example, and this one is two parts. So first, we actually have to find the circumference here. If we want to find the radius, the only relationship we have there is that the circumference is 2 pi times that radius. So we are trying to find r in this example. All right, so if it ever asks you to find the radius, if you're given the arc length and the arc measure, this is how you do it. We're still going to use that same formula though. And in here, we are actually going to be solving for C. So that's our goal first. This is step one, find C. So we need to know S. If we look at our arc length of EF, that's 10.5 feet. So that's S. We also know that theta, the arc measure, is 150 degrees. So let's fill those in. We have 10.5 over C equals 150 degrees over 360. And solving this is going to be the same as the last example, so if you want to tune me out and give it a shot yourself, go for it. But if we cross multiply, we end up with 150C equals 10.5 times 360. And let's go ahead and divide by 150 so that we get C by itself. Go ahead and plug that into a calculator to see what we get for the circumference. Should end up with 25.2 feet. All right, so that is our final answer. Step 2, we're going to take our circumference formula. C equals 2 pi times r. Well, we know what C is. We just found it. It's 25.2. We don't know what r is, but look at that. We can get it by itself by dividing by that 2 pi out front. So if you take 25.2 and divide that by 2 pi, we will get a radius of about 4 feet. All right, and you could have just as easily solved for the diameter. You could have used C equals pi times d and solved that. So these are a little bit trickier, but if you have questions, leave those down in the comment section below, or come find me if you are lucky enough to be a Central High School student. All right, well, I appreciate you guys tuning in, and we will see you next time. Adios.